5.7, compound interest. In the log module last year in Math 3, this comes up in the very, very, very last section in the homework only. The only way you saw this is if you were in the honors class. So I'm going to try and treat this as if you are seeing this for the very first time. Take very good notes. Practice using your calculator as we go through this. The main part students get wrong. It has nothing to do with plugging into the formulas. You guys are going to be very good picking the correct formula. Are we going to use compounded continuously or compounded so many times a year? That's easy because it'll tell you in the situation continuously or so many times a year. And then plugging in is also very easy into the equation. It's the calculator. So please take the time as we are going through, use your calculator. Now, speaking of calculators, I did not bring mine home and I don't want to wait to do this video. So I ended up just leaving the work that I have there. I will explain my process and use arrows and highlighters and stuff as I'm going. If you do need me to rework anything out tomorrow in class, please make a note of it and I will be happy to do that with you. Maybe showing you how to use your calculator if you are struggling with that. So simple interest, that's more of what you guys did in probably middle school. Finding interest of a very simple situation. You're just told this is what I start with, this is my interest rate, and this is for how many years it's going to grow. Being in big people math now, our interest is no longer simple. We have interest rates that are compounded continuously, which means that they will not stop growing. They are compounded all the time, or we have compounded so many times a year. And this is more of what we will see in the real world. Like my checking account and my savings account are each only compounded once a month. So they're compounded twice a year. 12 times a year. How many times a year is your in? So the difference between the two formulas, not much. A is your amount after the interest has been applied. Principal is your starting amount, what you put into the account. Rate is the rate that the bank is offering you. If it says 6%, then it's 0.06. So we need to make sure that we remember how to do that. So 6% would be 0.06. You must move your decimal place twice. Time is in years. So continuously, that's all you would have. This would be the formula that you would use, PERT for short. And then we have this messy looking one that's not as easy to use or to plug into the calculator. And these happen so many times a year. Now, they're not going to tell you once a year, twice a year, 5 times a year. They will tell you monthly, annually, semi-annually, weekly, daily, quarterly. You're going to have to know what that means. So I put some of the more popular ones here. If any others come up, Google it if you're not sure, or save that question for class. All right, let's get started. So again, I'm not going to be working any of these out for you because of not having my calculator, but I will explain where everything is coming from and talk you through how to plug into your calculator. So I have $50 invested. That's your principal. At 6%, that's 0.06. Compounded monthly, that's in 12 times a year. For 3 years, that's your time. Because we are using in, we use the ugly looking formula that does not have a cool name like PERT. So I plug everything in. 50 is your P, 6.06 is your R. Now 12 goes into 2 places. It's the denominator of your fraction and it's a part of your exponent. And then we multiply by T. So I plug in very carefully. So I have 50 plus the 1 is already there, or times 1 plus, then the rate is 0.06 over 12 times a year, and then it's 12 times a year for 3 years. So 12 times 3 gives me the 36. Now, in my calculator, I would do 0.06 divided by 12, hit equals, and then I would add 1. Do not take these numbers out of your calculator. If you leave them there, it is going to be very easy to work through this. If you're very good with your calculator, you will be able to plug this entire equation in as is and be fine. If you're not so good with your calculator, then go through this slowly. When I divide 0.06 by 12 and then I add 1, I hit equals. I take that answer, whatever this answer is, and I just hit caret 36. Then I hit equals. And then whatever this answer is, I want to multiply it by 50. So if you did everything right, you should get 59.83. And since this is money, we always round to 2 decimal places. All right, let's look at the next one. So here we have 100 invested. That's your principal. 10% is your rate, so 0.1. Compounded continuously. Oh, that's nice. That's the PERT for a period of 2.25 years. So 2.25, I'm going to plug in 2.25. So you have your 100, your rate, and your time. This is a lot easier in your calculator, but to get the E, don't forget E. You have to do second ln. So we might need a refresher on that in class tomorrow if you don't remember how to do that or where to find it. So in your calculator, this is very, very easy. This is a lot easier than the other one. It would be 100 second ln, so then that way E pops up. And then once you have that E that pops up, so it will look like this now. This would be 100 E. Then you put parentheses 0.1 times 2.25. Close the parentheses. And then you should get 125.23. Continuously is a lot easier than so many times a year. Example 3, just like example 1, we have $1,000. After we want to get $1,000, that means 1,000 is your amount after. So the entire question, I shortened this. It says, how much money would need to be invested to get $1,000 after 2.5 years at 6% daily? So daily is 365 times a year, which means we have to use the ugly formula. So I'm breaking this down a little bit for you because there's a little bit more work that you have to do because you're solving for P. So be careful. This goes in for A. P is what you are looking for because it says, how much do you have to invest? And P is what you invest. So I have 1,000 P times. I did all of this in my calculator. So all of this right here, I'll do over here for you. So I did 0.06 divided by 365. I hit equals. I got an answer, and then I added 1. Then I hit equals. I got an answer. I had already multiplied 365 by 2.5. So I did caret 912.5, and I hit equals, which gives me the 1.1618. Then I just need to divide that into 1,000 and I get 860.73. So I had to start with $860.73 in order to get $1,000 after 2.5 years. That's not bad for your money just sitting in the bank that you're going to make almost $140 and you did nothing. That's pretty good. Okay. So example 4, I'm not going to spend time on example 4 other than this is a comparison. You're given two rates, one that is compounded quarterly at 9%, and one, whoops, I meant to change the color, one that is annually at 9.25%. So you are starting with 1 year, $10,000. Unfortunately, it's not continuously, so you do have to use the nastier looking formula. The only thing that's going to change is the in and the rate, so be careful. Quarterly is 4 times a year. Annually is once a year. And the time is for 1 year, told us that back here. And we're starting with $10,000. So you just have to plug in. I have both of these numbers here. Make sure you can get them in your calculator, please. And which one would be better? The quarterly at 9%. You get $5 more. Now we're talking free money here, so I don't know why we wouldn't pick the one that gives us more money. Even if it's pennies more, the one that gives us the most money is better. Why would we turn down free money? Example 5. This is probably the most confusing example in this entire section. Find the effective rate of interest for 5% compounded quarterly. So even though it's 5%, it's really not 5% because every time we are compounding the interest, we have more and more money in our account. So really, by the time the year is finished, how much money have we actually earned? That's what we are trying to find out with the effective interest rate. What was the actual interest rate from start to finish for the year? And it will always be more than the initial percentage rate because you're increasing your money. If I start with $10 and it's compounded 4 times a year, maybe I have $11. Well, now when the interest is applied, they're applying it to $11 and not 10. And maybe now I get $13. And then when they apply it again, they're applying it to the $13, not 11, which maybe now I get $18, depending on my percentage rate. So I really didn't earn 5%. I earned more than 5%. So how do we find that amount? And if that doesn't make sense, that's fine. A lot of students really do struggle with this. So compounded quarterly, as soon as I see that, I know I'm going to use the messy looking formula. So find the effective rate of interest. The effective rate of interest is using just this piece here. That's all you need to use. You don't need to know how much you're starting with. You don't need to know how much you're ending with. We're just looking for the actual percentage rate. So that's all of this right here. The 1 represents that you are starting with all of your money. If I start with $1, that's what my interest rate is being applied to. So that's the 1. 100% of my initial amount. Plus, now my starting rate was 5%, so 0.05, compounded quarterly 4 times. And then we do this for 1 year. I want the effective rate for 1 year. They're not ever going to tell you the time. You are to assume that it is always 1 year. So I plug in the 1 year, 0.05 divided by 4, hit equals, add 1, hit equals, caret 4. And you get 1.0509. You ignore the 1. Remember, the 1 represented your starting amount. I'm not worried about how much money I started with. I'm worried about how much money I'm going to end with. And the interest rate that is actually being applied to my account is not 5%, it's 0.09%. It doesn't seem like much, but it is. If you guys are going to go out and buy a car and you have to make payments on that car, or you buy a house, the effective interest rate is what gets you. It's really not that percentage rate that they're offering you. You end up paying a little bit above that. So hopefully that makes sense. Again, you're just using the parentheses with the exponent. Let's say that I ended with 1, not a 7, 1.0732. Well, that tells me my interest rate started at 7% because of this 7 right here. But the effective rate, I ignore the 1 because the 1 represents the initial money that I started with. I want to know how much I made. If I started with 1,000 and I ended with $1,272.31, what was my actual interest rate to go from 1,000 to 1,272? And I get that from looking at the 7.32% instead of 7%. So it increases as your money increases, your interest rate goes up. So that's a good thing. All right. Last one is a homework question. I'm going to let you work on that first. Actually, well, you can write it down if you want. I don't remember if I gave this to you as a homework question. Interest rate is compounded annually, so N is 1. 3 years, time is 3. And then it just says, I want to double my investment. So pick a number. How much money are you going to plug in? And you want to double it. I went easy. I went with 1. I'm going to invest $1. And I want to double it to $2. So what does my interest rate need to be? That's what you're having to find. So you plug in for everything here. The only thing you're not plugging in for is R. Unfortunately, you have an exponent of 3, so you have to cube root both sides in order to get the 3 to cancel, which means decimal, but that's okay. You guys should be fine with plugging in the cube root, especially if you're using your phone. It's really easy to do cube roots in your phone. And then subtract the 1. And you get 25.99%. So if it is a homework question, great. If you have one like it, great. You can come back and get it. If not, pause it and write this down. And that wraps up our compound interest section. If you have questions, be ready to ask them tomorrow.